This is Tim Sandle, and I'm back with you with another video. And this video is going to be looking at cleaning and disinfection. Of course, cleaning and disinfection is an essential part of the contamination control strategy. So in this video, I'd like to talk about some of the key points relating to cleaning and disinfection of clean rooms. So what I'd like to cover is a little bit about clean rooms, very briefly, a bit about cleaning, detergents, disinfectants, how to select a good disinfectant, and also what makes a disinfectant work well or not so well. So let's begin with clean rooms. So clean rooms are contained spaces where we're seeking to control and to minimise the level of airborne particulates, to prevent those particles from settling out into surfaces, and to make sure that they are in continuous motion and then extracted from the clean room. So our biggest concern is with particles that might settle onto surfaces, and a number of these particles are going to be microbial carrying particles. We also need to minimise particles not only in terms of their distribution but also their sources of generation, and we may get an element of particles from equipment, but foremost our major concern is going to be from people. So we need to clean and disinfect surfaces, and there is a conceptual difference between cleaning and disinfection. So cleaning is the process of removing residues and soil, dirt, dust, protein, skin cells and so on from surfaces to the extent that they are visually clean. And cleanliness can be supported through environmental monitoring to help us to detect levels, and particularly things like total organic carbon swabs or water rinses can help us to kind of evaluate this concept of cleanliness. Because one of the other things that we're concerned about is not only the levels of cleanliness, but also be concerned about any residues of the detergents that we might be applying, because these residues could interfere with the disinfectants. So before we apply a disinfectant, it's essential that the surface or item of equipment has been properly cleaned before the application of the disinfectant. And this is in order for the disinfectant to work efficiently. So the activity of cleaning can also help to remove or dilute microbial populations. But even though a detergent might contain some chemicals that have some activity against microorganisms, a detergent is not a disinfectant, and no detergent is going to be designed to achieve total kill. So what do we mean by detergent? Well, a detergent is any chemical used to clean equipment or surfaces by removing of soil. And that's any kind of unwanted matter that might interfere with the activity of the disinfectant. And detergents work by penetrating soiling and reducing the surface tension. And it's this surface tension that fixes the soil to the surface. So we need to allow for its removal by reducing these physicochemical forces. And this is one reason why detergents are sometimes referred to as surface active agents or surfactants. And detergents will contain differently charged ions, and this can also act against the ability of microorganisms to fix the surfaces, causing them to repel against each other. And this can also make them easier to be treated by the disinfectant as they become disassociated from surfaces, because microorganisms in suspension are always easier to kill than those that are bound to a surface. The detergent that's selected, though, must be suitable for the intended use. So we need to understand the water quality. Some detergents work better with softer water. So if we are using hard water, we need to make sure that that hard water is not going to be inactivating the any of the properties of the detergent itself. And because there may be some residues remaining, although obviously we're trying to seek low to zero residues, we need to make sure that the detergent is indeed compatible with the disinfectant. We also want our detergent not to damage surfaces, to be non-foaming, and to be effective against all the types of soiling that might be present. So depending on what the particular types of grease, dirt, oil, protein, rust, skin, and so on are. And it's often the case that neutral detergents are ideal, and within aseptic facilities the detergents may need to be sterile. And here's a list of some of the commonly used detergents, but as I said, sterile neutral detergents are often the universal detergent of choice and the optimal one to use. Now then, disinfection. What do we mean by disinfection? Well, disinfection is either the inactivation or the destruction of microorganisms. And importantly, it's not the same as sterilisation, because we're seeking to reduce a population. We'd often measure that in terms of logarithmic reduction. And a standard disinfectant will only work against vegetative cells. It won't necessarily work against spore-forming microorganisms. For that, we need a special class of disinfectants called a sporicide. And we prove disinfection by qualifying the disinfectants against an appropriate standard. Depending on where we are in the world, there will be different national standards to choose from. And even though these differ in many ways, they do share some similar characteristics that we'll come on to. So disinfectants are a diverse group of chemicals. They're part of a wider group called biocides. Some are bacteriostatic, which means that they prevent the growth of microorganisms, but when the disinfectant effect ends, then it's possible for those microorganisms to be revived. And others are bactericidal, which means they have the ability to inactivate, destroy, if you like, the microorganisms. And the important factors that describe a disinfectant are defined through the active ingredient, and that's the thing that determines the mechanism of kill, which could be things like cell damage, membrane damage, the leakage or coagulation of cytoplasm, and full-blown cell lysis. And it's common to divide disinfectants up into two groups. We have non-oxidizing disinfectants that have more specific modes of activity. And these have a slightly lower spectrum of activity compared to the oxidizing disinfectants. They include things like alcohols, aldehydes, amphoterics, acid ionics, bioguanides, phenolics, and quaternary ammonium compounds, QACs, and these are probably the most widely used disinfectants in the world. And then we have the oxidizing disinfectants that have non-specific modes of action, but they have a wider spectrum of activity, and most of these chemicals are sporicidal, and they carry greater safety risks, and this includes halogens, oxidizing agents, things like peracetic acid, hydrogen peroxide, and also the chlorine-based chemicals, chlorine dioxide, hypochlorous acid, chloramine. So what makes a disinfectant work well or badly? Well, there are different factors. So we have things like the numbers of microorganisms. So obviously the more microorganisms there are, then the more challenging it is going to be for the disinfectant to achieve the widest level of kill. And most are going to be effective against lower populations compared to higher populations. In higher populations, we may get survivors or persister organisms. And then, as shown on the chart there, that some microorganisms are more resistant than others. So generally, gram-positive organisms are easier to kill, so skin bacteria. Gram-negatives, because they contain that additional layer of lipopolysaccharide, are more challenging. Then often we have fungi, then we have mycobacteria, they're waxy coats, and then we have bacterial spores, which in terms of typical cleanroom organisms are going to be the most challenging ones that we face. We also need to consider the location of microorganisms, so how tightly they're bound to surfaces, the concentration of the disinfectant and how optimal that is against the validated state. So we've got the risks of over or under diluting, or the loss of activity over time. So particularly if we're using a bucket method, after a period of time that activity is going to fade away. We also need to acknowledge that the contact time is also really important. So that's the time taken for the disinfectant to kill microorganisms. And importantly, it's the length of time that needs to be in contact with the microbial cell. So it's really important to keep surfaces wet to allow that to happen. We also have temperature, which is really important. So often the warmer it is, the faster the temperature reaction goes, and the colder it is, the slower that temperature reaction goes. So we can express that using the Q10 quotient, which normally means for every increase of 10 degrees, we get faster activity. Every decrease of 10 degrees, we get slower activity. And that's something to bear in mind when we're using disinfectants in cold areas, cold rooms, for example. pH as well can affect the activity of the disinfectant, and of course if we haven't applied detergent properly, we're going to get soiling, which can interfere with our ability to contact with the microbial cell and get that contact time that we desire. And also if we're using harder water, then the presence of those minerals can interfere with the activity of the disinfectant. So when we're selecting a disinfectant to treat a clean room, we need to think about a number of things. So the spectrum of activity is important. So what's the kind of typical range of microorganisms this disinfectant is going to be effective against? And does this actually reflect the types of microorganisms that we're finding within our facility? We probably at least want to have one of the disinfectants that has sporicidal properties. We want relatively rapid action, particularly for like an everyday in-use disinfectant. Sporicides always take longer in terms of their contact time. And where we're using two different disinfectants in rotation, as is a firm requirement under European good manufacturing practices, we need to make sure that the two disinfectants are compatible. So again, although we're seeking low to zero residues, we don't want the residue of one disinfectant interfering with another. We also want the disinfectants, as I mentioned before, to work against a reasonable pH and temperature range. And we also want good compatibility with different types of surfaces, and we need to understand how the contact time will vary against different types of microorganisms, against different surfaces. And we also don't want the disinfectants to damage the surfaces either. So we're trying to avoid corrosion, discoloration. So with the more aggressive disinfectants, particularly with chlorine-based substances, we would probably need to wipe away the residue, particularly where that disinfectant has come into contact with stainless steel. For use in aseptic areas, we need to make sure that our disinfectants are sterile. We need to have an understanding of the health and safety requirements. So some of the sporicides can be quite aggressive to the airway, so we need to equip people with appropriate respirators. And also how we dispose of the disinfectants is also important. We need to be conscious of the environmental impact. We also need to probably use our disinfectants using a variety of formats. So we're going to have choices between trigger sprays, pre-saturated wipes, concentrates that we may want to dilute up. So we need to understand these various factors. An important consideration with wipes is also with the quality of wipes. So we would try and avoid fibres and other particle causing materials that might be coming from the wiper itself. Now I mentioned validation earlier, so it's really important that all disinfectants have been qualified. And there are say different national standards, but they all share relatively common approaches. So an initial assessment is always through a suspension test. So this is basically evaluating the appropriate concentration in a test tube against an appropriate range of microorganisms. This is kind of a test that the supplier, the manufacturer of the disinfectant will be undertaking. For the user, then surface or coupon tests are very important, and this requires the application of microorganisms to the different surfaces, for the chosen concentration to be used, to measure the contact time, to then prevent any further activity through neutralization, and then assessing the number of microbial survivors and determining whether that is appropriate for the particular application. But perhaps the most important part of the disinfection qualification is the field trial, and this involves taking the disinfectant into our facility and evaluating how well it performs, and this involves lots of environmental monitoring before and after use and so on. And there's also things that we would want to go back and just sort of sense check, particularly before we introduce a new disinfectant into our facility. So is the disinfectant that we're going to be using appropriate? Has its effectiveness been periodically assessed? Do we have a strong scientific rationale for selection? We'd often want to have two different disinfectants so we can use those in rotation, and we'd want one of those to be sporicidal. And then we also may want to keep a third, perhaps a very, very aggressive disinfectant in reserve, just in case we have a major facility contamination control breakdown. And just to recap some essential rules is that any disinfectant will only be effective if it's used at the correct concentration, and we have an understanding of what the minimum effective concentration is likely to be. But equally, we don't want to use disinfectants that are overly concentrated, because the microbial cell may not take up the disinfectant, or it might register that disinfectant as being something toxic too quickly, and if it has the ability to have an efflux pump, it might then push out the disinfectant before it's had a chance to exert its antimicrobial effect. And we also have to have relatively clean surfaces to use for our disinfectant, and use the appropriate means to apply the disinfectant to the surface, because it's only through wiping that we're going to get the most effective disinfection activity. And we need to have a means that we're applying the disinfectant for the appropriate contact time. Okay, so thank you very much for your attention. Well, I hope you've enjoyed this video. So don't forget to subscribe to my YouTube channel. Thank you.